Hello students! Previously, we learned how a genius man named Dmitri Ivanovich Mendeleev back in 1869 tried to arrange the elements based on their physical and chemical properties. His attempts made him to form one table, which he called the periodic table of elements. Mendeleev formed a periodic table of elements having 8 vertical columns called groups and 6 horizontal rows called periods. Based on this table, he reached one conclusion. He concluded that the physical properties and chemical properties were interlinked. He then gave a law stating the properties of an element are periodic of their atomic mass. Thus, Mendeleev's periodic law states that the physical and chemical properties of the elements are repeated after a certain interval of time, as the elements are arranged in ascending order of their atomic masses. So today let us discuss some of the merits or achievements of his table. To start with, did you notice these question marks in the table? As discussed, there were some missing elements in the Mendeleev's periodic table. There is this gap between calcium and titanium, or zinc and arsenic, isn't it? Yes. Instead of looking upon these gaps as defects, Mendeleev boldly predicted the existence of some elements that had not been yet discovered till that time. Mendeleev firmly knew that there has to be some elements that would fit between calcium and titanium or other gaps. But at that time, there was no known element that would fit into these gaps. In fact, with this firm belief, he went on to predict the properties of these elements as well. He also gave them atomic masses. He wrote all of them on similar cards that he made for existing 63 elements. Not stopping at this, he also went on to name them. Mendeleev named the elements to be found in the space from the Sanskrit word eka, meaning first. Thus, Mendeleev named these compounds in relation to the element preceding the missing element in the same group. He added the prefix eka before the name of the preceding compound. For example, let's take an example of gap below aluminium here. He predicted the name of this compound as eka aluminium. Similarly, he named other elements such as eka boron and eka silicon. This means that the properties of all these elements should be similar to those of the elements placed first in the same group. Now you would ask me, is this some sort of achievement? I would say yes, it was indeed an achievement. It is because even when these elements were not discovered, their properties were found out or predicted based on the similarity in the properties of the preceding element. Eka aluminium was discovered soon, just as he predicted. It was found by a French guy, Paul-Émile, in France, who discovered it from the ore samples of the rock and named it after the historical name of the France, which was Gaul, as gallium. As predicted by Mendeleev, it was found that the properties of gallium matched to those of the aluminium. In fact, the atomic mass that was predicted by Mendeleev was also correct. That is 68, which is by far the most accurate. As we know today that its weight is 69.72. Similarly, eka boron was later discovered in Scandinavia and hence named scandium. Again, he predicted that its weight would be 44 and its properties would resemble to those of boron. And just like the previous, he was correct once more. Its weight turned out to be 44.9, just as Mendeleev had predicted. Moving ahead, eka silicon turned out to be germanium. discovered in Germany. Its weight was found to be 72.59, much like the predicted weight of 72. Moving on, he predicted the existence of Eka manganese 70 years before its discovery. It's true. This element, which we now call technetium, was so rare that it was not isolated until it was synthesized in a cyclotron in 1937. This is how Mendeleev designed a good periodic table, but also created a wider scope for future scientists to discover new elements. Let us see some more merits of Mendeleev's table. While Mendeleev was making table, the inert gases were not known. Now this is because they are inert and so do not react much. And also, their low concentrations in atmosphere made their discovery late. Inert gases such as helium, neon, argon, etc. were discovered very late by Lord Rayleigh and Sir Ramsay in 1894. So now if these gases were made to fit in between the existing elements, this would mess up the table, isn't it? Yes. But the arrangement of elements given by Mendeleev was so systematic at that time that these inert gases could be easily arranged in this periodic table without the slightest disturbance. They could be easily arranged into altogether different columns. Did you observe anything else in the table? We find that in some places, the elements are not in ascending order of their atomic masses. For example, iodine and tellurium. Can you find any other such pair? Yes, here they are. Now this is because Mendeleev emphasized similarities in properties rather than increasing order of atomic mass while arranging these elements. Therefore, iodine, though of smaller weight than tellurium, is placed later as it resembles more to chlorine and bromine than oxygen and sulfur. Similarly, cobalt and nickel or aluminium and silicon do not follow the increasing atomic mass pattern of the periodic table. Well, this is one of the limitations also. Yes, Mendeleev placed elements with higher masses first and the elements with low mass after them. But it is credible that he chose chemical properties as important over the atomic masses as a property. Thus, he gave more weightage to similarities in properties than order of the atomic mass. And thus, he made the given arrangement. So this becomes merit as it paved way to further classifications. Another big thing that Mendeleev's table could do was correct the atomic masses of elements like platinum. Yes, he said that the masses of these elements were wrongly estimated. And to all of surprise, their true masses were later re-estimated and correctly written. Now you must be thinking that such a genius who could predict the existence of so many new elements or could point out wrong masses would have made a perfect table, isn't it? But sorry, this disappoints you. His table also had some limitations, which we will discuss in our next video.